Good morning guys, it is me Divagaran. Welcome to my channel DIVU'S. Today we can study one problem that is also from matrices. Find the minors and cofactors of all elements of determinant A where A is given a matrix and hence find A inverse. That is the question. You listen, we can find out the minors first. A is given, how to find its minors. You listen, first minors and cofactors I have written like this way. Look here, minus, if you listen, you can understand M11, first minor, first row and first column you got. What is the element you are getting? 3, that is the first minor. M12 if you want means first row and second column you got. So what you are getting? 4, that is M12. Then M21 means second row and first column, second row and first column we avoid. So what you are getting? -2. Next one comes last M22. That is corresponding A22. Therefore we are getting M22. M22 means second row and second column you avoid. Second row and second column. So what is the element left there? 1. So we determine the minors. Now how to write cofactors in easy way? You listen. A11 if you want. You think about what is 1 plus 1? 1 plus 1 is 2, which is an even number. If it is even number, same thing you can write as cofactor. So A11 is equal to 3 itself. See A12 if you want, what is 1 plus 2? You are getting 3. 3 is an odd number, so you should change the number, this one, 4 to -4. If it is -4, you have to write +4. So A12 you determine. Next one comes A21. A21 means what is 2 plus 1? 2 plus 1 is 3 again. So you should change the sign. -2 comes means here it comes +2. Then last come A22. How to get A22? A22. 2 plus 2 is 4. 4 is an even number. Even number comes in same thing we will write. 1. That is 1 itself. So we got these are the cofactor elements of each of that determinant. Cofactor of each element of that determinant we found. Now we can write the cofactor A matrix. So this is first row, this is come A11, A12, this is first row. So it comes cofactor A equal to 3 minus 4, first row. Second row is coming here, 2, 1, that is 2, 1, that is second row comes there. Therefore cofactor A is equal to 3, -4, 2, 1. Then we can move to adjoint A. What is adjoint A? Adjoint A is the transpose of cofactor. Cofactor is we determine cofactor. Adjoint is a transpose. Transpose means first column will become first row will become first column. So first row is 3, -4. 3, -4 is coming as 3, -4 first column. Second row is 2, 1. That is coming as second column. So this is adjoint A. So how to determine A inverse? You know the formula for A inverse. A inverse equal to 1 by determinant A into adjoint A. What is A inverse? 1 by determinant A into adjoint A. That is A inverse. So A determinant A, how to find determinant A? You have written here, see 1 minus 2, 4, 3. You will write the symbol like this way. Determinant means determinant 1 minus 2, 4, 3. Determinant of Tobato matrix is very easy. Just you multiply 1 into 3, 3 minus 4 into -2, it comes as -8. So 3 minus -8 comes 3 plus 8, which is equal to 11. Which is equal to 11. So we got the determinant A is 11. If determinant is 0, if determinant A equal to 0 gets means we can say that A is a singular matrix. So no need of finding, no inverse exists because 1 by 0 means no value. It just doesn't mean, so we cannot find it means we cannot find the A inverse. If A is a singular matrix, if determinant A equal to 0, it means that A is a singular matrix. If A is non-singular, that means A not equal to 0. Determinant A not equal to 0. Determinant A is not equal to 0. It is 11. So we can find A inverse. So A inverse equal to 1 by determinant A, 1 by 11 into adjoint A. This is adjoint A. See, A inverse equal to 1 by 11 into adjoint A already we found that we will write here. So we found A inverse by finding minors and cofactors. So in easy, if it comes for exam, that is for any entrance exam or anything, you can write it easily without writing minors and cofactors. You think about, see, this is A. See, to write adjoint A, it is easy. Look, no need of writing minors or anything. Just you turn this one. This just interchange 1 and 3. This first diagonal. This is called principal diagonal. That elements you can interchange 3 and 1. 3 will come here and 1 will come here. Look here. For a 2 by 2 matrix, 3 and 1 we interchange. And next you change the sign of this diagonal. This diagonal elements are that you change the sign. 4 will come as negative 4. Negative 2 will come as positive 2. So once again I tell you, this principal diagonal, this is called principal diagonal elements you can interchange to write adjoint easy. 3 1 1 3 you can write as 3 1, and this one what we can do, this one we can write we can change the sign of that elements. So 4 will come negative 4 and negative 2 positive 2. So I have written. So no need of writing all these minors and cofactors. Easily we can find it. Understand clearly? So this way we can find A inverse. I think all of you understood clearly. Thank you.